Alright, assalamualaikum everyone. So in today's video, we will be doing the May June 2020 paper 1-2 of physics, O-level physics. So let's start. This is going to be the part 1, doing question 1 to 20. So they say which quantity is a vector. So vector is something which has a direction as well as a magnitude. Time is scalar, it only has a magnitude. You say it's 230, you don't say it's 230 to the right, 230 to the left, right? Speed is also scalar, I hope you know that, and distance is scalar as well. Acceleration, however, is a vector. Now, speed, the vector corresponding, something which is similar to speed is velocity. Displacement is a vector similar to distance. So whenever direction becomes important, that is where something becomes a vector. In question number 2, they say that the diagram shows the resultant R of a 3 Newton force and a 4 Newton force that act at a point P. They're saying that the angle between the 3 Newton force and the 4 Newton force can be any value between 0 and 90. So it can be basically 4 Newton over, this is 4 Newton over 3 newtons. This will be when there's going to be 0 degrees, and then it can be 4 Newton and 3 Newton in this direction with an angle of 90 degrees. So they're saying which value of R is not possible. Now for any such question, just to the two, make the two possibilities like this, all right? Because it's saying any value between 0 to 90. So when it's 0 degrees, we have something with the magnitude of 7 Newton. So the resultant is 7 Newton. In this case, I hope you know that if you make a tip to tail diagram, so let's make 3 Newton here, the resultant is going to be from here tail to tip of the other one, and it's going to be 5 Newton if you use the Pythagoras theorem. So it means that from 0 degrees to 90 degrees, the value can be anywhere between 7 Newton to 5 Newton. So any value of the resultant which lies outside of this range is not possible. 7 Newton is possible, 6 falls under there, so it's possible, 5 is possible. What is not possible? 4, because it does not fall in this range. Okay. Question number 3, which is measured by using a micrometer. So micrometer screw gauge is used to measure length. Very easy. They're saying stopwatches are used to time the runners in a race. The stopwatches show the times recorded for the winner and another runner. And they're saying what is the difference in time between the runner and the other runner. Alright, so basically, if you see, this is up to centiseconds. So centiseconds is what? If this is 1 second, centisecond means this, because centisecond is 10 to the power of minus 2. I hope you know that. And kilo is 10 to the power of minus 3, and deci is 10 to the power of minus 1. So this 1 over 100 is representing exactly that. You can represent in a digital stopwatch to a 1/100th of a second, which is basically this. So this can be represented as 57.76, all right, and this can be represented as this is going to be minutes. So this is going to be 1 minute and 3 seconds and 84 milliseconds. So what is going to be the difference between the two? Now 1 minute can be translated to 60 seconds, so this will be 63 seconds and 84 centiseconds. So if you find the difference between these two, which is 63, my bad, 0.84 and 57.76, you get something of this is going to be 8, this is going to be 0, this is going to be 6. So 6.08 is the answer, which is B. I hope that made sense. Question number 5. Two cameras are a known distance apart. The exact time that a vehicle passes each of the cameras is recorded. What can we obtain from the information? Now, if you know the distance between 2 points, let's say point A and point B, you know the distance between the 2 points, and you know the time over here and the time here when the car passes. So you know basically the time difference is the time taken to go from A to B. So if you have the distance and if you have the time, what can you find out? You can find out the average speed. Why? Because between any 2 points, if you have the distance and you have the time, you can find the average speed. Why did I say average speed? Because, well, the speed can be varying along this journey, right? So we take out the average by taking total distance divided by total time. To find the instantaneous speed, you need to find the distance of that exact point and the time of that exact point. Right now we have the time and distance for the entire journey, so that yields the average speed. Now they say that a car of weight 1100 Newton moves with a constant velocity along a horizontal road. A driving force of 5000 Newton acts on the car. They're saying what is the force opposing the motion? Now remember that constant velocity means that acceleration is zero, because acceleration is the change in velocity. And if acceleration is zero, then according to the Newton's second law, if acceleration is zero, then resultant force needs to be zero, right? So resultant force is zero. Resultant force zero means that if this is the car, then whatever force is acting forward is being cancelled out by whatever force is acting backwards. And so if the forward force is 5000 Newton, then 5000 Newton must be acting backwards. How come? Well, let's say because of friction between the tire and the road, or let's say because of air resistance. So it is only when these two are going to be equal to one another that the resultant force, at least in the x-axis, will turn out to be zero. And so the answer would be A. Alright, so question number 7. A man with an open parachute falls to earth at constant speed. The following forces act. You can read these through, and they're saying which two forces are in Newton's third pair law. Now, remember, Newton's third pair law says that the forces are equal in magnitude, opposite in direction, and act on mutually different bodies. So, here's a parachute, and here's the guy, and so the P is the upward force of the parachute on the man. So P is the force which is pulling the man up, and that is being done by the parachute. And Q is the upward force of the man on the earth. So if this is the earth, the force that the man pulls, uses to pull the earth up is Q. Now, if you don't know about this, I can't really discuss it in this video. It's a very, very long concept, but one day inshallah I'll tell you how does that even make sense. And R is the downward force of the earth on the parachute. So the earth is pulling the parachute down because of its weight, obviously. That is R. And then the downward force of the man on the parachute, and so the man is also pulling the parachute down, and this is S. Now remember, in Newton's third law pair there are always two bodies which are acting on one another. If you look over here, in P, parachute is acting on the man. In S, the man is acting on the parachute. They are opposite in directions. So that tells us that P and S are going to be obeying the Newton's third law. Question number 8. The diagram shows a motorcyclist leaning over in order to turn the corner to the left. Which force causes him to turn? Now, every single time you want to turn about a roundabout, or whenever you want to move in a circular motion, there's a force which always acts towards the center of the circle. It is known as the centripetal force. Not many people introduce this term in O levels, but you're taught that whenever there's circular motion, there's a force acting towards the center. So if this guy is trying to turn, it's going to be something like this, right? It's basically a circular motion. So whenever your car even wants to turn about the roundabout, friction is going to act as the force which it's going to act towards the center of the circle as the centripetal force. So over here, if the force which will cause him to turn or to move in a circular motion is going to be A, because remember, you always the centripetal force, or the force which causes something to come in circular motion, always acts towards the center of the circle. Okay. Now they say an object weighs 40 Newton on Earth where the gravitational field strength is 10 Newton per kg. The object is taken to a planet where the gravitational field strength is 4. And they're saying which row is correct. So if we really think about it, on Earth, I know the weight, which is 40, and I know g, which is 10. So the mass is simple to find out, right? Because it's weight divided by g, so that's 40 divided by 10, and that is 4 kg. Now, mass does not change whether you are on Earth or Mars or the moon, does not matter. The mass does not change. And so the mass of the object on this whatever XYZ planet we're talking about will remain as 4. Now, if I know the mass, I can find out the weight of that object on the other planet, because the weight is equal to mg. I know the mass is equal to 4 and the g is equal to 4, so that will be 16, and the answer would be B. Alright, now they say that the diagram shows the equipment used to determine the density of a liquid. Now, density, remember, is rho, which is m over v. Alright, so v is simply the volume of the liquid which is in this beaker, so we can get rid of C and D. Now, m is the mass, right? So the way that you find the mass of a liquid is you first weigh the mass of the beaker alone, alright? and then you find the mass of the beaker and the let this be m1, and then you find the mass of the beaker plus the liquid, and let's call this m2. So when you subtract m1 from m2, you actually are left with the mass of liquid, because we can't find the mass of liquid otherwise, right? Because it's just going to flow over the mass, the balance. So that's why it's going to be mass of beaker and liquid minus mass of beaker, and that will give you the mass of the liquid. Because if you have x plus y, this is the mass of beaker and this is the mass of the liquid, and then you also weigh x, which is the mass of the beaker, and you subtract these two together, you're left with y, right? You're left with the mass of the liquid. So I hope that makes sense. The answer is A. And now they say which single item can be used to find the center of mass of a plane lamina of irregular shape. Now they're saying which single item. So the way that we do this is simply using a vertical pin, or otherwise we also use a pendulum and things like that. But one thing that is very very essential is a vertical pin by which we can hang this irregularly shaped plane lamina, and it can swing and suspend freely and come to rest with a center of gravity exactly below this point of suspension. I hope you know that. Question number 12. A student makes a model toy which balances on the end of a metal rod. Why are the weights needed? So basically, they're saying that a student makes a model toy, all right, which balances on the end of a metal rod. So this is a metal rod and it balances on top. And they're saying, why are the weights needed? Now, this is all about stability, more or less, right? So when you want to make a toy, you want to make sure it does not fall very easily. And so one way that you can increase the stability is actually by increasing the mass, or you can say by increasing the mass at the bottom, and what that, or you can say, increasing the weight at the bottom, what that does is it lowers the center of mass, all right. And that helps. There are actually two things that affect stability: the center of mass, the lower it is on an object, the more stable it is, and secondly is the base area. So the greater the base area, the greater will be the stability. In this case, he's actually adding weight somewhere in the middle. So he's actually lowering the center of mass below the top of the rod. Otherwise, it would have been somewhere at the top. So a student makes a model toy which balances on the end of a metal rod. And what this does is it basically makes it more stable. Now, question number 13. It says that an unstretched elastic cord of length 15 centimeters stretches by 4 centimeter when a weight of 6 Newton is suspended from it. The cord does not exceed the limit of proportionality. What is the total length of the cord when the weight is 3 Newton? So here's the thing. You have a elastic cord, all right, and it was initially of 15 centimeter, and then it actually stretched by 4 centimeter when we applied a weight of 6 Newton. So they're saying the cord does not exceed the limit of proportionality. What is the total length? Now this is actually about Hooke's law, which is F is directly proportional to E, and we know this is equal to F is equal to KE, where K is the spring constant. And for a material, K is a constant provided that the limit of proportionality is not exceeded. So you can actually find this out by doing F is equal to E. So when we apply a force of 6 Newton, the extension is of 4 centimeters. So that leaves us off with 3.2, which is 1.5. Now, using this K, because the limit of proportionality is not exceeded, I can consider this K to be 1.5 and then also equate it to another F over E, in which case our force is 3 Newton and extension is what we are interested in right now, at least for now. So this will basically be 1.5 is equal to 3 over x, and so x is going to be 2 centimeter. Now remember that this is the extension and not the total length. They want you to find the total length. The length initially was 15 and the extension is 2 centimeter when you apply a force of 3 Newton. So the overall length would be 17 centimeters. So the answer is D. Moving on. Now they say that an object is placed at different depths in liquids of different densities. Which liquid at what depth is the pressure the greatest? Now the hydrostatic pressure in liquids is basically equal to rho gh, and so the greater the density would be and greater the depth would be, the higher will be the pressure. G, we can treat it as a constant because G does not change, at least when we are on Earth, and that's what we're going to assume. So if you want the greatest pressure, you want the greatest density. So in that case, we will look at C and D, where the density is 1200 greater than 1000. The depth then again should be greater for greater density. So the depth, we have 4 and 10, and I'll definitely prefer 10 because that's a greater depth, so that means greater density. Because remember that pressure is directly proportional to rho, pressure is directly proportional to h. So greater the density, greater the height, greater the pressure. Question number 15. So there's a small vessel of volume 3 cubic centimeter which contains air at a pressure of 100 kilopascals. And they're saying, well, there was a small vessel we connected it with a syringe. The piston was fully inside, and then we slowly started to move the piston outside. It created a volume inside the syringe of 12 cubic centimeters. So they're saying, what is the pressure of the air in the syringe? So this is a question of Boyle's law, which is P1 V1 is equal to P2 V2. Now, the pressure initially is simply in the small vessel, which is 100 kilopascals, and the volume is 3. I'm not going to care about the units because they are same on both sides. And now, once you move the piston out, you create a room of all of this volume for the air to rest in. So you create, I don't know about the pressure, but we know that the volume we create is almost 15 cubic centimeter. And so this is 300 divided by 15, which is 20 kilopascals. And so the pressure which is going to be inside this system, and also as well the syringe, is going to be 20 kilopascals. And so the answer is A. Now, moving on to question number 16, they say that a rocket of mass m, when empty, carries a mass m of fuel. The rocket and fuel travel at speed v. The engine of the rocket is fired and all of the fuel is expelled. They say that the speed of the rocket increases to v. They're saying what happens to the kinetic energy of the rocket. So, we know that kinetic energy is equal to half mv square. So right now we're talking about the velocity. Kinetic energy is directly proportional to the velocity. Now initially the speed was v, now the speed is 2v, so the speed has actually become twice its initial value. So kinetic energy is directly proportional to v square. So when velocity increases 2 times, what happens to kinetic energy? It increases by 4 times, and so it increases by a factor of 4. Alright, a car of mass 1000 kg is driven 200 meters up an incline so that it rises 50 meters vertically. The acceleration is this, and they're saying what is the gain in gravitational potential energy. So here's a car, right, and it moves up to this point. So gravitational potential energy is mgh. The mass is 1000, and the acceleration free fall or g is 10, and the height is 50 meters. So this would be then 500,000 joules. And so the answer would be C. Okay. Then they say in which situation is energy being released by the fusion of hydrogen nuclei to form helium. So when it's this phenomena of fusion of hydrogen nuclei to form helium actually happens in the sun. I hope you know that. It's known as nuclear fusion. So, yep, the answer would be D. Now, talking about 19, the main stages in the operation of a coal-fired power station are listed. They're not in the correct order. They're saying, the flow chart shows the first two stages. What is the correct order? So, let's see. The turbine turns the generator. Water is boiled, becomes hot. Well, first of all, what we need to do is that, you first need to burn the fuel or whatever you're using, right? So you first burn the coal, and first of all, that will make the water in the boiler hot. And it makes it so hot that steam is produced, all right? And when steam is produced, that steam actually turns the turbine. So it's three then. And that turbine, in turn, then you can say that turns a generator, and then this generator in turn, with the help of it kind of generates electricity, and with the help of electromagnetic induction. So the answer is then 5. So the order is 6315, which is A. Then they say in which situation is there no transfer of energy? A car battery turning the starter motor, a car moving along a horizontal road at constant speed, a solar panel warming water, a spacecraft orbiting the earth at constant height. Now, the thing is that when a car is even moving at a constant speed, yes, there is constant speed, and constant speed means that the kinetic energy is constant, which is true. But don't forget that there's going to be, there's still going to be a transfer of energy, right? Although the kinetic energy is constant, does not mean that the mechanical energy is not being converted to kinetic energy. It just means that if 20 joules has to be converted, then 20 joules is being converted, more or less. There's also going to be frictional forces which need to be overcome in this scenario, so the answer cannot be B, although it seems like the tempting answer. And then they say a car battery turning the starter motor. That obviously requires energy because the chemical energy in the car battery is being used to do some mechanical work, which is to basically turn the starter motor. So it can't be A either. Then they're saying a solar panel warming water. Now, definitely, when this solar energy comes in and water absorbs it and makes its internal energy, that for sure is. There is a transfer of energy, so it can't be C. Now we look at a spacecraft which is orbiting the Earth at constant height. So if this is the Earth, here is a spacecraft and it is orbiting the Earth at constant height. Now its distance from the center of the Earth is the same, and so there's no difference in the gravitational potential energy. There's no work that is being done for that. And if you look at it, it is just orbiting, right? It's just moving in these directions, different directions, right? But the every single time that something is moving in a circle, there's a force which is acting towards the center of the circle F. But in order for energy to be transferred, we say that work done is a way of transferring energy. So work done, even if we talk about that, that is F into D, right? Now the centripetal force always, or the force that makes something move in circular motion or orbit, is always acting towards the center of the circle. But for work done, the distance moved should also be in the direction of the force. But when something is orbiting the Earth, it is never, never, never moving in the direction or towards the center of the circle. It is, in fact, moving always around, right? So it's moving here instantaneously, and then here, and then here, and then here, and then here. The point is, the force and the distance are never in the same direction, right? So no work is being done. So no energy is being converted. So इसलिए इसका आंसर D होगा. So I hope you found the first part of this question paper useful. If yes, give it a thumbs up. See you next time. Khudafis.